Hello, Mr. Brainy here. The lesson we're going to look at is 2.2, Scientific Notation with Positive Powers of 10. The essential question for this lesson is how can you use scientific notation to express very large quantities? And our Common Core standard is 8EE.3. Use numbers expressed in the form of a single digit times an integer power of 10 to estimate very large or very small quantities and to express how many times as much one is than the other. Okay, that's a mouthful. So, scientific notation is where it gets introduced. It's also going to be in the rest of this module. Scientific notation is a method of expressing very large or very small numbers as a product of a number greater than or equal to 1 and less than 10 and a power of 10. So let's make some sense of that. So scientific notation, I'm just going to call it, use SN as my abbreviation for that, has two parts. It's a number times 10 to an exponent. Okay, this number that goes in that first box has to be greater or equal to 1. So it can equal 1 or it has to be bigger than 1, but it has to be less than 10. So I like to just say it's between 1 and 10. It's okay for it to equal 1, but it can't equal 10, if that makes sense. So between 1 and 10 is maybe the easiest, the most simplest way to understand it. So I got a number between 1 and 10 times 10 to an exponent. If it looks like that, it's scientific notation. So let's look at this example here. The weights of various sea creatures are shown in the table. Write the weight of the blue whale in scientific notation. So here is my table. The blue whale is right here. The weight of the blue whale is 250,000 pounds. So this is the way we're going to do it. Move the decimal point, I'm reading part A, in 250,000 to the left as many places as necessary to find a number that is greater than or equal to 1 and less than 10. So what number did you find? So let's show that in action here. I'm going to write it on the right side without a comma. So here's my decimal point. Yeah, if it's a whole number, my decimal point's always after the ones place. So we're going to move it to the left so that we end up with a number between 1 and 10. So if I move it over once and put the decimal point there, so we have a new ones place. This number is 25,000. That's not between 1 and 10. Move it over again. That's not between 1 and 10. Again. That's getting closer. That's still not between 1 and 10. Okay. So if I move it here, right, between the 5 and that 0, it's 25 because the 5 is in the ones place. That's still not between 1 and 10. So I actually have to move it here one more time. So I end up with the number 2.5. And all you got to do is ask yourself, is 2.5 between 1 and 10? And it is. So this next part is, it explains how you can get this power of 10, but I'm just going to show you this different way. You can divide 250,000 by 2.5. You can divide it. Even use your calculator and double check it. But one way is count how many times we have moved decimal, because that has to do with powers of 10. I had to move it 1, 2, 3, 4, 5, which means it's going to be 10 to the 5th power. Part C says combine our answers to the last two parts, so that the number 250,000 is the same as 2.5 times 10 to the 5th power. Okay, just to use some vocab here, 250,000, we call that standard form or standard notation, right? I use that term when we're dealing with exponents. And then the second part, we call this scientific notation, right? That's the name of the lesson. Okay, so sometimes I might say leave your answer in scientific notation or write your answer as standard notation. Let's go on to the next page. This first part on the top it could be very helpful. It's going to show you an example, also with an explanation of what exactly you're doing, writing it in scientific notation. We're going to skip that and go ahead to trying some problems. So the your turn, number 3, 4, and 5, all really big numbers. If you could give those a try, please pause it and then check your answers when you're done. Number 3 is 6. Let me actually show you the decimal point being moved. So if the decimal point is right after the ones place, then I'm moving it over 3 times to get 6.4. That's my number that's between 1 and 10. And since I had to move it 3 times, it's 10 to the 3rd. Number 4 is going to turn out to be 5.7 times 10. I'm going to skip count here. So I want my decimal point needs to be between the 5 and the 7. So I'm going 3, 6, 9, 10, 11. So 10 to the 11th power. Now when I'm writing, when I'm grading others' work, one of the most common things that are missed is that some students forget to write the 10 because it's always 10, right? So it's easy to forget because they don't have to figure that out. What they have to figure out is what's the new number and how many times did they move the decimal. So don't forget the 10 because it's an important part of this. Number 5, it gives you a little context in number 5, but you're still doing the exact same thing. This huge number is the Lightyear, it's the distance that the light travels in a year, which is called a light year. So this huge number written in scientific notation is going to be 9.461, right, since I had to move the decimal point between the 9 and the 4, times 10 to the, let's skip count, 3, 6, 9, 12. So 10 to the 12th power. Okay, let's go on to the next page and see what else we have. We may also need to take numbers that are written in scientific notation and then write it into standard notation. So it's just going backwards. What you just have to remember is that if my exponent is positive, it's making the number bigger. So my number is going to be very big. So if I have the your turn number 8, and pause it, by the way, if you want to give these a try, or pause it maybe after number 8. 7.034 times 10 to the 9th. The 10 to the 9th means I'm going to move this thing over 9 times. So if I move it over 3 times, I get past the 4. Then I got 1, 2, 3, 4, 5, 6. I need to put zeros in where I did not have a number already there. And then this last 0 I just wrote is my new ones place. So my new number, or my number in standard notation, is this, a very, very big number. 7,034,000,000. Number 9, 2.36 times 10 to the 5th power means I'm going to go 1, 2, 3, 4, 5. And where I did not have any numbers, where I moved the decimal, I put zeros. The last zero is my ones place. So my new number is 236,000. And the last one, the mass of one roosting colony of monarch butterflies in Mexico was estimated at 5 times 10 to the 6th grams. Write this mass in standard notation. 5, the decimal goes right after that. 5's in the ones place already, so decimal point goes after that. I'm going to move it over 6 times. Right, zeros go in those blank spots. And I have my number. It is 5 million. And because it gives me a context, I'm going to write the unit grams. And that is it for this lesson. Thank you for watching. Goodbye.